Today's problem is LeetCode 3047. Find the largest area of square inside two rectangles. We are given n rectangles on a 2D plane, and all of them are aligned with the x and y axes. Each rectangle is described using 2 points. Bottom left, I, gives the bottom left corner of the rectangle. Top right, I, gives the top right corner. So for every rectangle, we know its exact position and size on the plane. Now here's the challenge. We need to look at the overlapping region between at least 2 rectangles. Inside that intersection, we want to fit a perfect square. Our task is to find the maximum possible area of such a square. If no 2 rectangles overlap, or if a square cannot be formed inside their intersection, then we simply return 0. The final answer should be the largest square area that fits completely inside the overlapping region of any 2 rectangles. Example 1. Input. Bottom left equal to 2D array of 1, 1, 2, 2, 3, 1. Top right equal to 2D array of 3, 3, 4, 4, 6, 6. Explanation. Here, we check the overlapping regions between every pair of rectangles. A square with side length 1 can fit inside the intersection of rectangle 0 and rectangle 1, or the intersection of rectangle 1 and rectangle 2. Any square larger than side length 1 cannot fit inside any overlapping region. So the maximum square area is 1 times 1, which equals 1. Output 1. Example 2. Input. Bottom left equal to 2D array of 1, 1, 1, 3, 1, 5. Top right equal to 2D array of 5, 5, 5, 7, 5, 9. Explanation. The rectangles overlap vertically. A square with side length 2 can fit inside the intersection of rectangle 0 and rectangle 1, or the intersection of rectangle 1 and rectangle 2. A square larger than side length 2 will not fit. So the maximum area is 2 times 2, which equals 4. Output 4. Example 3. Input. Bottom left equal to 2D array of 1, 1, 2, 2, 1, 2. Top right equal to 2D array of 3, 3, 4, 4, 3, 4. Explanation. In this case, multiple rectangles intersect together. A square with side length 1 can fit inside the overlapping region formed by any 2 or more rectangles. No larger square can fit. So the maximum square area is 1 times 1, which equals 1. Output 1. Example 4. Input. Bottom left equal to 2D array of 1, 1, 3, 3, 3, 1. Top right equal to 2D array of 2, 2, 4, 4, 4, 2. Explanation. In this example, none of the rectangles intersect with each other. Since there is no overlapping region, it is impossible to place a square. Therefore, the answer is 0. Output 0. Intuition. To place a square inside 2 rectangles, the square must fit entirely inside their overlapping region. So the real problem becomes, for every pair of rectangles, find their intersection area. Inside that intersection, what is the largest square we can fit? Key observations. A square is limited by the smaller side of the intersection. If 2 rectangles don't overlap, we skip them. We just need to track the largest square side length found so far. Finally, square area equals side times side. Let's walk through this solution step by step. We are given 2 2D arrays. One for the bottom left coordinates of rectangles, and one for the top right coordinates. Our goal is to find the largest possible square that can fit inside the overlapping region of at least 2 rectangles. First, we initialize a variable called max_squareside. This will store the largest square side length we find so far. We also store the total number of rectangles, so we can compare them pair by pair. Next, we use 2 nested loops. This allows us to check every unique pair of rectangles. For each pair, we calculate their overlapping region. To find the overlap, the left boundary of the overlap is the maximum of the 2 left x coordinates. The right boundary is the minimum of the two right x coordinates. The bottom boundary is the maximum of the two bottom y coordinates. The top boundary is the minimum of the two top y coordinates. These four values define the intersection rectangle. Now we check if the overlap is valid. If the left boundary is less than the right boundary, and the bottom boundary is less than the top boundary, then the rectangles do overlap. Inside this overlapping region, the largest square we can fit is limited by the smaller side of the overlap. So we calculate the overlap width, the overlap height, and take the minimum of the two as the square's side length. We then compare this value with our current maximum and update it if needed. This process continues for all rectangle pairs. Finally, once all comparisons are done, we return the area of the largest square, which is the side length multiplied by itself. If no rectangles overlap, the result remains 0. Final output. The function returns the maximum square area that can fit inside the intersection of at least two rectangles. Alright, now that the logic is complete, let's quickly test our solution. I'll click Run to verify it against the sample test cases. As expected, all test cases pass successfully. Now let's hit Submit. And there we go. Accepted. This confirms that our solution correctly finds the largest possible square area that can fit inside the overlapping region of at least two rectangles. And that's it for today's LeetCode problem. In this video, we compared every pair of rectangles, found their overlapping region, calculated the largest square that fits inside that overlap, and returned the maximum possible square area. If this explanation helped you, don't forget to like, share, and subscribe for more daily LeetCode solutions explained step by step. See you in the next problem. Happy coding!